Okay, any question? Okay, today and Wednesday, two classes, we will cover chapter 15, scheduling. Scheduling is assigning and providing instructions. If there are multiple works, jobs, then assign who will do that job, and then which machine will do that, and then when, assign like that, and then provide detailed instructions. Converting the production plan into day-to-day directive for workers, how many, when, which machine, and then which job first, and the next, and so on. And objectives of scheduling. Then we can meet due date, like until due date, 10 days left. Then if certain work maybe 5 days, at least 5 days earlier, start to meet due date. So schedule that job or work and minimize lead time, setup time, and work in process. And also effective scheduling can lead machine utilization improve. So maximize machine utilization. Capacity and scheduling. If capacity is here, then infinite loading. Disregard this capacity, just a schedule, maybe over the capacity. If that day, that week cannot complete, then maybe carry over to next week. And finite loading. Schedule under the capacity. So regard that capacity and schedule. Scheduling method, forward scheduling and backward scheduling. Forward scheduling, scheduling each operation when system take on order. When system take on order, start process or working, that is, okay. System, when system take an order, starts, that is make to stock order system. Why this one is not good? Anyway, so for the scheduling, if a company system use make to order system, then I use this for the scheduling. It's like this. If there are multiple stages or works in a system, from customer, order come, and then this need parts or a component, but this one doesn't have because this one make to order system. So ask part, and so on. Then a supplier send the parts. So this one doesn't know when part come, but this one ask parts to supplier. Then supplier said, we will send that 2 days later. So this one can schedule like a 2 days later start. So this one schedule. And the next one, this one, we will send you 4 days later. So this one can schedule, this one can schedule and schedule like this. So schedule order this way. We call this here upper and then lower, downstream, upstream and downstream. So water like a flow from upstream to downstream, and then scheduling order is the same. So this is forward scheduling. And next one is backward scheduling. Backward scheduling, production activities are scheduled by their due date. The same if there are multiple stages in a system. By due date, schedule, so they know due date sometime. So this one starts, it's like the due date is 10 days later. Then this one should start at least 10 days earlier to meet the due date. So schedule this one. Supplier. So to meet due date, schedule this one first, second, third, and fourth. So from downstream to upstream, scheduling order this way. So this is now backward scheduling. We don't cover MRP system yet, but MRP system is a traditional system. So traditional scheduling, and this one also make 2 stock system. So make 2 stock system, traditional system, use backward scheduling. Make 2 order system, use forward scheduling. And then make 2 order system, we will cover JIT system. JIT system is make 2 order system, and use forward scheduling. Excuse me. And resource and scheduling. If machine time is limited, that is kind of capacity. So if they are concerned about the capacity, then based on that limited machine schedule, labor hour limited, then based on this limited labor hour schedule. Job sequencing, the process of determining which job to start first on some machine or in some work center. So if there are multiple works, then determine which works first and then second and so on. That is job sequencing. Rules, priority rules for the job sequencing. First come, first serve, FCFS. Many cases we use this one. Whoever come first, then give service or produce some first. SOT rule, shortest operating time or processing time. So among multiple works or operations or process, shortest first, and then second and third and so on. STR rule, select time remaining rule. Select time remaining is time remaining before due date minus remaining processing time until due date 10 days. Then the processing time 5 days, and then that 10 minus 5, that is the select time. Whichever select time shortest select time job first and second and so on. STR over OP rule, select time remaining per operation. Select time divided by number of remaining operations. So using this ratio, shortest first and second and so on. Due date rule, whichever shortest due date first and then second and third. And critical ratio, due date minus current date. This is the remaining date divided by the number of works days remaining. So using this ratio, shortest, smallest first and second and so on. LCFS, last come, first serve. I never seen using this rule. And then random, just pick randomly. Example, if job A come first, B second, and so on, then their processing time, operation time, 3, 4, 2, 6, 1 days. And then due date, 5 days left, 6 days, 7 days, and so on. Then if we use FCFS rule, first come first service, then take A first, B second, C third, and so on. Then flow time, because this one come first, so 0 start 0 time starting time plus 3, so flow time is 3. And then if B come right after A, then wait 3 days until job A done, and then plus processing time for the job B. So 7 flow time, 9, 15, 16. So total flow time for all jobs to complete all jobs, 50 days. And mean flow time, because now 50 total flow time divided by the number of jobs, 5 equals 10 days. On time job, job A, due date is 5, but finish in 3, so meet due date. 6 days left for B, but finish in 7th day, so 1 day delay. 2 days delay, 9 minus 7, and 6 days late, and 14 days late. So on-time job is only A, and then others, miss due date, late jobs, B, C, D, E. And then average lateness, 0 late, and 1 day late, and so on. So total lateness divided by the number of jobs, 5 equals 4.6 days. And other rule, if we can use an SOT rule, shortest operation time rule, then now job order job E, processing time is 1, shortest, so take this one first, and then C, second, and so on. So flow time, total flow time 1, 3, 6, 10, 16, 36 days. Mean flow time 7.2. On time job E and C. Due date is 2 days later. Complete in 1 day, mid due date, and then mid due date. But others 1 day late, 4 days, and 7 days. So average lateness, if we use SOT rule, then 2.4 days. Due date rule, shortest the due date, remaining time, job E, and then A, second, B, third, and so on. Total flow time 39, mean flow time 7.8. On time job E and A, and then B, C, D, late, and then average lateness 0.0237 divided by 5 equals 2.4. If we use LCFS back order like E, D, C, B, A, and then total flow time 46, 9.2 mean flow time, 2 jobs mid due date, others miss due date, 4.0 average lateness. Random rule, just take randomly, then 53 days of total flow time, 10.6 days mean flow time, on time A, others miss due date, and then 5.4 average lateness. If we use the STR rule, then 43, 8.6, 2 jobs mid due date, and then BCD miss, and 3.2 average lateness. Compare those rules, then total flow time. Among them, SOT rule is shortest, and mean flow time, of course, shortest. And then average lateness, 2.4, 2.4 due date rule, and the SOT rule, the same. Anyway, among those rules, SOT rule, if we can use this SOT rule in real world, this is the shortest scheduling rule, and then always work like that. Okay, scheduling method. Scheduling n jobs on 2 machines. Many cases in our life, if this is now regular class, face-to-face in class, then usually I print out the lecture note and then make a copy and then distribute in class. But this time it's online, so I don't make a copy. Our school, Marriott University, copy machine is old one. So make a copy. Then there is no staple function. So after making copy, then I staple myself. So it's like a 2 machine. If one machine do all jobs, then only 1 machine need. But our school copy machine is old one, no staple function. So it's like a 2 machine or 2 jobs process. And also, when we laundry, when we do laundry, wash first and then move to a dry machine, or hang like this, the breeze and then the sun make the dry. So 2 machines if we need. Then first step, list. By the way, this rule is Johnson's rule to minimize the flow time, total flow time. So list operation time for each job on each machine. And then step 2, select the shortest operation time. If the shortest time is for the first machine, do the job first. If it is for the second machine, do the job last, and then repeat step 2 and 3. Step 1, among operation times 3, 2, 6, 8, 5, 6, 7, 4. Among those, this one is shortest. So take job A. And then this shortest time for the second machine. So do the job A last because it's on second machine. So place job A last. And then remaining times, job A already assigned, so close out. Then 6, 5, 7, 8, 4, 6, 4. Among them, 4 is second shortest. So it is machine on machine, second machine on the second machine. So do the job D second last. So place job D second last. And then remaining times 6, 5, 8, 6. Among them, this one 5 is shortest. So take C, and then this time is for the first machine. So do the job first. So place job C first. And then last, job B, first machine, and then place here. So job order is C, B, A, D, A. Based on this Johnson's rule. Then total flow time will be like this. Job C goes machine 1, and then job B wait until job C finish, and then place. Then job C goes to machine 2, and so on. So total flow time is 25. This is if we use this one, then shortest total flow time. Okay, you have practice problem. On Moodle, you can download this practice problem. The practice problem looks like this. Download now this file and then try. Okay, I will give you 5 minutes. Try. If you try this one, then you will know if you something don't know. But if you don't try, then you will not know. What you don't know. So try. And then if you have a question, ask me. Is there any question? Doing okay? Daniel.
Yep.
Are you trying now?
Yep.
Mm-hmm. How about Cameron?
I'm trying it.
Okay, good, thank you. Anybody has answered, then let me know. Anybody? David. David, can you hear me? Okay, I will give you answer. Let's do it together. Okay, among them, this one is the shortest. So job 5. And then this one is for the first machine, first operation. So place job 5 first. Then cross out. Then remaining times, this one, shortest. So take job 6. First machine, so place job 6. Second first. And cross out. Remaining times, this one is shortest. So take 4, job 4. Second machine, so this one, place last and cross out. And then this one, shortest. Take job 7 here. And this one next shortest, job 2. This one second machine, so job 2 here. And 6. Job 1, second machine. Then last one. Compared to your answer and my answer, do you have a right answer?
That's what I have.
Okay, thank you. Good.
I do now.
Okay, good. Okay.
No, I had it differently. I thought the question was saying that we would go like sequencing between A and B. So I had it
and
alternating like machine
uh-huh.
A, machine B.
Mm-hmm.
So
So say again, among those operation times, the shortest time, if it is the first machine, then do the job first. And then if it is for the second machine, do the job last, not alternate. Okay?
yeah.
Okay, thank you. And next one. Personnel scheduling. Scheduling consecutive days of restaurant or any business. Sometimes now more employee or worker need day to day. like a weekday. You know what? Like a market on Friday, more customer come, especially every other week Friday, because it's like a payday. That case, that business need more workers, and maybe Monday and Tuesday, the demand or customer size drop. That case, less number of employee or worker need. So during a week, all week, from Monday to Sunday, maybe different number of workers need. That case, how can we assign the number of workers need? That is personnel scheduling in services. Find the schedule that minimize the number of 5-day workers with 2 consecutive days. So usually we work 5 days and then 2 days off. So using that rule. Step 1, assign the first worker to all of the days that require stepping. Circle the 2 consecutive days with the lowest numbers. And then step 2, for worker 2, subtract 1 from each of the days not circled with positive numbers and enter this in the worker 2 row. Okay. Explain this one with an example. If this business need 4 workers on Monday, 3 workers on Tuesday, 4 workers Wednesday, 2 workers Thursday, 3 Friday, 1 Saturday, 2 Sunday. Then it says assign the first worker to all of the days. Just copy required number on worker 1 row. Then circle 2 days like this. Come on. If we circle 2 days, Monday and Tuesday, then summation is 7. If we circle Tuesday and Wednesday, then add the 2 numbers, then 7, 6, 5, 4, and 3. So among those combination, 2 days and consecutive days, this one is shortest. So circle there. That means worker 1 will assign Monday, Tuesday, Wednesday, Thursday, and Friday. Not on Saturday and Sunday. So for worker 2, because worker 1 is assigned, so subtract from Monday 1, Tuesday 1, Wednesday 1, Thursday 1, Friday 1. And Saturday and Sunday, worker 1 doesn't assign. So remain the same numbers. So change like this. 4 minus 1 is 3 because worker 1 assigned. -1, 2, -1, 3, -1, 1, 2. Remain the same number because now worker 1 is not assigned. And then the same 3, 2, 5, 2, 3, 5, 3, 1, 4, 1, 2, 3, 2, 1, 3, 1, 2, 3. There are 3 tie. 1, 2, 2, 1, 1, 2. If there are 3 ties like that, multiple ties, then ask worker 2 which day you want to work, don't work. Then if the worker 2 choose Friday and Saturday, okay, then -1, -1, -1, -1, -1 remain the same. So change numbers. And then same 2, 1, 1, 2, 2, 0, 2, 0, 2, 1, 1, 1. So also there are 3 tie here, and here. Then ask workers 3, and then workers 3. I will not work Saturday and Sunday. So circle there, and then subtract. And same, and so on. So here on Monday, worker 1, 2, 3, 4 assigned. On Tuesday, worker 1, 2, 3 assigned. Wednesday, worker 1, 2, 3, and 5 assigned. On Thursday, worker 1 and worker 2 assigned. Friday, worker 1, worker 3, and worker 4 assigned. And Saturday, worker 4 assigned. And then Sunday, worker 3 and worker 2 and worker 4 assigned. So assigned like this. And then required number 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 2, 3, 1, 2. Satisfy required number of workers. This is personnel scheduling rule in service. Any question?
Could you go back a slide, please?
Here?
Yeah, I just didn't finish the last row.
Okay. Okay.
Thank you.
Thank you. Okay, any other question? Okay, then next rule, next method. Scheduling a set number of jobs on the same number of machines. Assignment method. Scheduling a set number of jobs on the same number of machine. If there are 5 machines and then there are 5 workers, then assign 1 to 1. This assignment method is a special case of transportation method of linear programming. We will cover linear programming later. Linear programming, limited resource in a limited resource environment, then how can we assign machine or destination and so on. So assignment method is now one of the linear programming method. Then there are n things to be distributed to n destination. So it's the same number, 5 machine, 5 worker. In case, if there are 5 machine but 4 workers, then we make a dummy worker and then match the same number. Each thing must be assigned to one and only one destination. So match 1 by 1, 1 to 1. Then use only one criterion can be used. So like minimize cost, minimize time, or maximize profit, and so on. So use only one criterion, not multiple. Okay, example. Okay, you will take a quiz, actually number 2, that is from chapter 11. Next week, next Monday, I remember the schedule. And then you will take a quiz number 3 from this chapter. And the quiz question from this method. This method is somewhat complicated. So follow my steps. So listen carefully. Okay. If there are 5 machines and jobs, then how can we assign 1 to 1? So those numbers cost. So if job 1 is done by machine A, then $5. Machine B, $6, 4, 8, and 3, and so on. Then step 1, subtract the smallest number in each row, because this one is cost. So find the smallest. If they are like a profit, then find the largest, because they are cost. So minimize. So try to minimize the total cost. So subtract the smallest number in each row. So on this row, 3 is smallest. So subtract this smallest from numbers on the same row and itself. So 5 minus 3 is 2, 6 minus 3 is 3, 4 minus 3 is 1, 8 minus 3 is 5, and 3 minus 3 is 0. Change it like this. And then next row, 4 is smallest, subtract from all numbers and itself. And next row, next row, next row. and like this. So on your lecture notes, I made like a steps. So this is maybe a second table I made. And then step 2, subtract the smallest number in each column. So column, smallest, 0, 0, 0, and 0. So this column, this column, this column, this column doesn't matter because smallest is 0, but this column, positive smallest. So subtract, then change. 3, 5 minus 2 is 3, 2, 1, 1, 0. Are you with me?
So far, yep.
Any question? Doing okay? Okay, next step. Determine if the minimum number of lines required to cover each 0 is equal to n. For this example, n is 5 because there are 5 machines and then 5 jobs. So using line, cover all 0, horizontal line or vertical line, it doesn't matter. If the number of the line is the same as n, for this example, if we use 5 lines to cover all 0, then we can get optimal solution. But if the minimum number of lines less than 5, then we need another step. Okay, let's try to cover 0, 0, 0, 0, 0, 0 here. Always, if you follow this, then it's not complicated. But without my rule, then it will be complicated. When you cover 0, if there are 2 or more zeros on the same row or column, cover that row or column first. Okay, here on this column, there are 2. On this row, there are 2. So cover this column and this row first. Okay? If you doesn't cover 0, then maybe you use more line to cover all 0. Then it will be the answer will be wrong and then complicate. So say again, if there are 2 or more zeros on the row or on the column, cover that row or column first. Here, this column, there are 2, and this row, there are 2. So cover this one and this one first. And then remaining 0 here and here. It doesn't matter using a vertical or horizontal, it doesn't matter. I will use horizontal line to cover this one, and then vertical line for this one. The number of lines, 1, 2, 3, 4. I used 4 lines to cover all zeros. The minimum number of lines required to cover all zeros is 4. It's less than n of 5, so we need another step, step 4. Step 4, subtract the smallest number not covered by lines. This one, this one, this one, and they are not covered by lines. Subtract the smallest among them. This one or this one is smallest among numbers not covered by lines. So 1 is smallest. Subtract from this one, this one, this one, and so on. So 2 minus 1 is 1, 2 minus 1 is 1, 5 minus 1 is 4, 0, 4, 1, 2, 1, 0. Change like this. And then try again, cover all zeros using lines. There are 2 0 here, so cover that. There are 2 0, this cover this column. And there are 2, and then there remain here and here. So you may cover this row first because there are 2, but I use this one. So anyway, cover and cover. So minimum number of to cover all zeros is now 5. The same as n, 5. So we can get optimal solution. The minimum number of lines required to all zeros is now 5. It is now equal to n. So 0 is on for job 1 on C and E, 2, B, 3, C, and so on. So like this. Then how can we assign? I will show you. Okay, for job 1, 2, 3, 4, 5. Job 1 on C and E. C and E. And then 2 on B. And 3 on C. 4, B and D. 5, A and D. Okay. Job 2 and job 3, only one available. So assign only one available job first to machine. So if we assign B, then this one is not available. Then D is only one available for job 4. So assign, then not available. then assign, and then assign only one available, then not available, then assign. So job 1 assigned to E, job 2 assigned to B, job 3 assigned to C, 4 to D, 5 to A. Okay, so if we assign like this, then find the original, from original table, the first table, find cost. If we assign job 1 to machine E, then $3, 2 to B, $4, 3 to C, $2, 4 to D, $5, and 5 to A, $3. So total cost will be $17. There are many steps, but if you practice with my steps and then what I said, then it will be okay. Not much, not too much complicate. Any question? If we don't have a question, then stop here, and then on Wednesday, we will I will cover a practice problem and then previous quiz question. Okay. If
Yeah,
you
I
don't
don't
have a question,
understand-
yeah.
I don't
Yes.
understand where those costs came from, because they're not matching up to what was in the first line.
First table, the initial table.
Mm-hmm. Yeah,
Okay,
it
go back,
had
go back, go back.
$5, $6, $4, $8, $3.
So if we assign, okay. This one is the initial table. So job 1 assign E, and job 2 assign B, 2 to B, and 3 to C, 4 to D, 5 to A. So total is 3 plus 4 plus 2 plus 5 plus 3 equals 17. Okay.
Yeah, I see now.
Okay, good. Thank you. Okay, any other question? Okay, good. And see you Wednesday. Wednesday will be hybrid. So in class with the Zoom. So if you want to come in class, face to face, see you in class, and others see you on Zoom. Okay, bye.
Have a good one.
Thank you.
Bye, thank you.
Thank you.
Good night.
Thank you.